thing that happened during our day.
If it'll load.
That's Spanish.
And that test for Space never, ever revise the checks or tests.
If I do one more quiz and someone has to go over there and ask her, check your answers, man. How do you mess it up every time? Yeah.
There was one question that was true or false. The answer was false.
And
didn't
both
have any
answers
false
are
on
true
there.
on the thing. How
Okay.
do you do it every time?
So we are starting with example F from the notes, which is the integral of 9r squared dr over the square root of 1 minus r cubed. I use dr because my variable's an r.
Oh, wait, never mind.
Okay, so I know I'm going to be using u substitution on this one. So the first thing I need to do is identify what my u is. Anybody have an idea?
1 minus r cubed.
1 minus r cubed is my u because it is the inside function that is inside of the radical. What do I do next?
Du.
Find my derivative of u, which is what?
3r.
No.
Negative.
3r squared. Negative 3r squared dr.
There you go.
Oh, shoot, my bad.
My derivative is negative 3r squared dr. Then what do? I don't take the antiderivative yet. I need to reorder this so that my entire
You have to
du
get
is grouped
negative
together.
3r squared dr. You have to get that in.
I do. Do I have that in there right now?
No, you need to divide by negative 3.
So I can separate the whole number 9 into negative 3 times negative 3, which will give me my negative 3r squared dr. So that's what I'm going to do here. This becomes the integral of 1 over the square root of u times, negative 3 over the square root of u, because I separated the 9 into negative 3 times negative 3. I left one here and moved the other one here. By doing this, I can replace negative 3r squared dr with du. And that leaves me with negative 3 over the square root of u du. Then what do I do? Nope.
Nope, take the antiderivative.
I want to anti-differentiate this. Before I can do that, though, I should probably turn this into a fractional exponent, and I should move everything to the top because it allows me to anti-differentiate easier. So that is the same as the integral of negative 3u to the negative 1/2 du. To make it even easier, I'm going to take my constant negative 3 and I'm going to put it in front of the integral so I don't have to do any computation with it. So this becomes negative 3 integral u to the negative 1/2 du. And now I can take the antiderivative of u to the negative 1/2 du. What's that going to be? I'll give you guys a second to figure it out. I would like the antiderivative of u to the negative 1/2 du. So that's reverse power rule.
I wish there was a
Say that again. It is not.
Negative 3u 1/2 over
Well, what's
1/2,
negative
which is
Plus 1 is positive 1/2. I like that part, but it's not over.
It's 2.
It's 2u to the 1/2. Good. So this is negative 3 times 2u to the positive 1/2. Of course, I can multiply that negative 3 in. And don't forget it has a plus c on it. So this becomes negative 6u to the 1/2 plus c. And then I replace my u with the 1 minus r cubed that it was originally. You could also go ahead and rewrite that as a radical instead of a rational exponent if you so choose.
Why did we save that one?
Huh?
Why did we save that one for that? You said last time you're not gonna.
Because I gave you G to do on your own, and I didn't think that this would be a good one to have you do on your own quite yet. That's why I saved this one. So either one of those are acceptable answers.
Oh, that's sad. Not writing it like this.
That's perfectly fine. Either one of these are okay, whichever one you're more comfortable with. I personally prefer the radical part, but that's me.
probably on the AP test, it's gonna be the radical part.
They could give it to you either way.
How many? Wait, are we just doing examples today?
Yes.
How many?
However many we can fit in.
The whole class.
However many we can fit in. Okay, so we already did G. That was the one I had you do on your own yesterday. So now we're gonna go ahead and move into H. And this is the integral of secant of the theta plus pi over 2, tangent of theta plus pi over 2, d theta. So theta here looks scary, but it's just like a variable. It's an unknown value.
How it's fine.
Yeah, I don't mind.
Oh, because it's not gonna do anything. It's not gonna be in the derivative, and then we plug it back in like theta.
I am still going to treat this like a U substitution problem, even though you could do it without that. So treating it as U substitution, what is my inside function U? Theta plus pi over 2, which means that the derivative of that inside function is going to be what? 1, because derivative of pi over 2 is 0. Derivative of a variable is 1. Times d theta, because I have to indicate that I took the derivative. Of course, you don't have to have the 1 there, so this is the same as du equals d theta, which makes it really, really easy to work through this one. So now I can do all of my replacing because I have a d theta here, and then all of my inside functions are already there. So then this becomes the integral of secant u, tangent u, du, and I can anti-differentiate that.
Why do you want to?
Is that just secant?
Because I have to have the D letter match whatever my variable is. Sorry, who said that, Deanna?
It's secant.
It is just secant. So my antiderivative here is what?
Secant
Plus C, good.
u plus c.
Yep.
So secant theta.
Secant of theta plus pi over 2 plus C. How do we like that one?
Where the heck did tangent go?
The
No, I think
tangent was put in there when I took the derivative, so when I undid the derivative, it disappeared.
Do you have tissues?
I do not. I'm sorry. I keep forgetting to bring them.
You want to get rid of those books?
They're supposed to.
But they're not going to.
Just put
Yeah,
them
they-
outside of your
Just
door,
get rid
so
of
they
it
have
yourself.
to take them.
They are supposed to. Mr. Booker was in here. We were talking about them earlier.
Get rid of them yourself.
Let me just walk out with a big pile of
No,
books.
they have a cart. You just throw the books in.
I know
No.
they're emptying out that
Put them.
textbook closet.
Oh.
You throw your books in there. You put the cart back in the closet. They empty it out.
If
Yeah,
you put them
there are
outside
books
of
in there that were old when I was in school, 10 years ago. Yeah, it's like that.
Wait, what was it
They
called?
probably all white and have to write.
Women in fiction. Lovely.
Actually, like, no. Whenever you read it.
You guys have 4 to use as you choose.
When are we
Yeah,
having
you
the-
said you would give us some because we don't, you said we'd have like pizza days, like every other week or something like that.
That was my goal, but we keep
But
having
we
these
could
snow
do
days.
something else.
They're messing with me.
No, I'm gonna
She's
be
got a
honest.
point.
And we've never done one, we've not had
She said
any.
that in October, the day she came back. What are you
Yeah.
talking about?
That was my goal, okay? We'll see what we can do. Anywho,
No.
I have the integral of 3 times the quantity sine of x to the negative 2 power dx. What am I going to do?
I knew, sign of a.
You is fine. So then,
I'm going to show you something a little bit different
Uh-uh.
because it's going to be fun.
yeah, well,
Your definition of fun is not fun.
Why do you do that? Why can't we just do it like we do?
If you
Is
were
it
going
easier?
to do it like you do, you're going to end up with 1 over sine,
Just
and then it's still going to be ugly. So the way I'm going to show you is we're not going to end up with any fraction in our answer. So just accept it. We're doing it, okay?
why haven't you done this one?
Because it didn't apply. So the first thing I'm going to do is I'm going to pull that 3 and I'm going to put it in front of my integral so I don't have to worry about it. So this is the same as 3 times the integral 1 over sine of x squared dx. I have a question.
wait, why is it 1 over? Oh.
because that's what was inside. What is 1 over sine of x? Cosecant. It is cosecant. So then this is the same as 3 times the integral of cosecant x squared dx, which I know is going to work out perfectly because cosecant has a really nice antiderivative that's not going to give me a fraction. So now I can go ahead and do my u substitution. I identify u as what? Cosecant of x, good. What is my du then? What's the antiderivative of cosecant?
Is it
Cosecant.
1 over?
Nope. I heard part of it in there. The derivative of cosecant is cosecant cotangent. But what's the antiderivative of cosecant? Specifically,
Negative.
yeah, sorry.
Wait, why wouldn't it be cosecant cotangent?
It would be cotangent. Yes.
I don't think you ever told us that, because I was looking for that one day in my notes, and Liam was like, you don't need that, and I was like, but I can't find any.
Cosecant squared is
Yeah. Okay, point it out again.
cosecant squared is cotangent.
If I have cosecant squared, which I already had there, I didn't have to use u substitution. So then I know the antiderivative of cosecant squared is negative cotangent squared. But not negative cotangent squared, negative cotangent of x. And then I don't have to worry about that. Because I was just able to anti-differentiate this. So this becomes 3 times negative cotangent of x plus c, and then I put the 3 and the negative cotangent together to get negative 3 cotangent x plus c. So you don't always have to use u substitution even when it looks like it is that type of problem, because we have identities that help us change trigonometric functions into something easier to work with. So you should definitely go back and review those reciprocal identities and even the Pythagorean identities. They may be helpful.
Pythagorean.
Should we write those down?
Probably.
Feel like we really should. Not today, but we will.
What are they? Just give me
Yeah,
a-
Shepherd.
So if you did it the other way, would you still have the
If you did it the other way, sine, cosine. It should, in theory, yes. I work for it, but this is the better way of doing it.
We get this question on the HVAC thing, then they have it that way, we have it the other way, and then we put no answer. And they mark it
This
wrong.
would not be on the HVAC thing. They would give you one that can be solved 2 ways. Not like
I
this.
don't know, some teachers are kind of dumb.
Depends on if I write the test or not.
Oh. Not teachers are wrong.
And you write the test.
I am eligible to write the test this year, yes.
We want J.
I smell like strawberries.
That's the lotion. So this one is none that we have to switch out. So as I'm looking at this, Ethan, what is my inside function? Cotangent x. Rotering, what is the derivative of my inside function? I'll give you a second to look, that's fine. The more we do these, you should try to commit them to your memory though. Would been, well, I think we wrote them down too, didn't we? I thought we wrote them down.
We did. I'm pretty sure. On the back. On the first.
Yeah, I thought we wrote these down on the first page.
Only some of them, not all of them.
I don't think we did the inverses, but I thought we did all of these base.
No,
What?
you did
Just
trigonometry,
cosecant squared.
you did like the basic trigonometry.
Yeah, these should be one of the base ones.
Not.
This one.
Yeah, we just did that.
Okay, never mind then. It's when we did trig derivatives earlier then.
Cotangent is-
Negative cosecant.
And it's the, yeah.
Okay, so what are we seeing? It is.
It's gonna be negative cosecant.
It is going to be negative cosecant squared x and then
Yeah.
dx.
You heard me just sit here saying that right?
Yeah.
I did hear you too. I was just trying to get Rotering to say it. Next time, it's fine. I'll call you on the next one. So then what can I do here? Do I have a negative cosecant squared dx?
Yeah, well, you have a positive.
I have a positive, which means I have to make it negative.
So would you put a negative outside? Or?
I will put a negative outside, which will put a negative inside. So then this becomes -1, the integral of the square of u. I went ahead and put that in so I don't have to write cotangent of x. And then times negative cosecant squared x dx. That directly matches what I need my du to be, so I can replace it.
So one still stays in front.
Just the negative or -1, it doesn't matter. And I end up with the negative integral of the square root of u du. Then what do I do? I would change that to a fractional exponent and then take the antiderivative, yes.
Wait, so if I put the negative back, it's gonna give me a different answer.
Say that again.
If I put the negative back in right now,
No, with-
It's not gonna change anything.
no, with one half.
It's not gonna change anything.
3/2.
yeah, because you guys are gonna get 3/2. But if I put the negative in, I get 2 here.
Or just get -2. The 3/2.
Like if you put the negative in front of the u right now, it's not gonna change anything. Because you're still going to get negative u to 1/2, so it's still gonna be negative u to the 3/2 divided by 3/2. It doesn't go to the exponent.
Wait, where did that? Oh, I put it in front of the square root, so I did. To the
Right.
negative.
Yeah, no, that doesn't work. The negative only applies if I was in the denominator. Okay, so what's the antiderivative of u to the 1/2? Okay, 3u to the, no, not 3u.
-2.
2u to the 3/2 over 3. Remember, we flip it when we multiply it in. So it's gonna be the negative of 2u to the 3/2 over 3. And then of course I can apply the negative in there and then have my plus c on it. Ethan, do you see why it's not 3 over 2?
Yeah.
Okay. Make sure you flip it because we want to cancel if I were to multiply it down. And then I'm done. Right?
No.
No, what do I have to do? Put
Oh.
the u back in. Please do not forget to do that.
Can't do these problems without you.
Thank you.
Very funny. Where's 3? There you go.
So the cotangent.
Questions, concerns, or issues thus far?
We're just getting this as you keep putting problems.
Stop it. Oh my goodness.
The integral sign's weird. I don't like
If we have more than z number of problems,
We do not have more than z number of problems.
What, how many are there?
Problems? I think I went all the way through. Oh wait, no, that's the wrong one. That's the wrong one too.
And
she went to x.
I went through O and then I did one more after that.
Dang, I was close.
Nope, just kidding. I did 4 more. I did more.
are we ending at O today?
We're in C. We're in try to.
Mathematic results. Yeah.
Example K. The integral of tangent to the 7th of x over 2 times secant squared of x over 2 dx.
Secants.
Why is it supposed to be said?
Yes, it's supposed to be a 7. If it helps you at all, we can also recognize that this is the same as tangent to the x over 2, all to the 7th power times secant squared of x over 2 dx. If it helps you to realize what's happening, you could also write it like that. They mean the exact same thing.
7.
It doesn't really help.
If drop it prime, if I were taking the derivative, but I'm going to go the opposite way. So this does help because it helps me identify what my inside function is.
X over 2.
Tangent.
What?
Tangent of x over 2 here is my entire inside function.
Are you kidding me?
Nope.
But there's
Wait, I was spacing at that whole time. I don't mind you. How did
Because it's inside the parentheses, which makes it
Yeah,
an
but-
inside function.
how did you?
I just moved the exponent
Let me see. What,
from here to there because they mean the exact same thing.
sorry about that.
No, you're perfectly fine.
I was not. I was thinking about everything.
Why did I choose tangent as my inside function when technically I could have done the same thing with secant?
It's got
No.
bigger exponent.
Okay, it has a bigger exponent, which indicates it's probably the inside function. But what's the derivative of tangent? Secant squared. So I know that this is part of my derivative. I have to keep in mind what could be happening as I pick what my inside function is. I can almost guarantee it's always the one with the highest exponent. So I have my u. This allows me to go ahead and find my du. We already established that the derivative of tangent is secant squared, right? So it's secant squared x over 2 times, we're missing something.
Yeah.
Nope.
No.
You have to do chain rule because I have something other than an x inside my parentheses. So it's going to be secant squared of x over 2 times the derivative of x over 2, which is what?
1, 0.
1/2. Because that's the same as 1/2 x. And then times dx. Of course, I'm going to reorder that to make it look a little bit nicer. So this is the same as 1/2 secant squared of x over 2 dx. Are we all okay with how I got that? Is that present in my function?
No.
Not even close.
But can I make it be there?
No.
Yeah.
Yes. All I have to do is I have to put a 2 in front of my secant squared. So when I put a 2 there, I also have to take the 2 out by putting a 1/2 out front. So then this becomes 1/2 times the integral. I'm going to make that u. So u to the 7th times 2 secant squared x over 2. Oh, not 2. Opposite.
That's right. That's right.
I put a 2 out front to cancel out the 1/2 that I had to put inside. Once that perfectly matches, I can go ahead and eliminate that and replace it with the du. So this becomes 2 times the integral u to the 7th du, and then I anti-differentiate like normal. Hold on, I'm gonna call on somebody for this one. So I'll give you a minute to write it out, and then I'll call on them. Anti-differentiating that. So taking the antiderivative. Once you get it down to a u and a du, you're ready to take that antiderivative. Rotary, I'm gonna call on you. Okay, so rotary. I have u to the 7th du. How do I anti-differentiate that? Okay, so tell me what you know. And then divide by the new exponent. So this becomes 2 times u to the 8 over 8. Then what? So multiply the 2 in, right? That's going to reduce. So this becomes over 4. So I have u to the 8 over 4. Is that all that's in my antiderivative? Or am I missing something that I have to add to the end? Plus c, and then I'm ready to do what? Everybody, put my u back in. So then this becomes tangent of x over 2 to the 8th over 4 plus c.
Can we put a tan?
This is the
You could put tan to the 8th of x over 2 over 4, or you could put 1/4 tan to the 8th of x over 2 plus c.
This is a good explanation for like algebra, or like math. You're the problem. You're the issue. Not the problem.
Okay, that works. How do we feel about that one?
It's okay.
Was it the worst thing ever?
I just wanna be done.
I know, we're not done. I know.
It just gets harder. That's all.
I don't know how to tell the ones that we're done with.
The question mentioned two different ways to solve. Are you gonna put them on the test?
That have more than one way.
Yeah.
Or I might say use reciprocal identities to rewrite and then anti-differentiate. Like I'll give you a clue that you're supposed to use something else.
Okay.
And I still won't know what I'm supposed to do.
Well, I will have helped you as much as I can. Okay, example L.
I'm freezing.
I'm sorry. Erin, do you have an idea of what we can do first? Okay. We could find U, or I could use a reciprocal identity to simplify this to look a little bit nicer before I do that.
Quick question, if we didn't do that, would our inside function be sine squared?
No, it'd be the sine of 3x all squared.
So it'd be sine of 3x.
And then you'd have to chain rule it and whatnot. Okay, so what I would like to do is I would like to separate that dx from the top. Because I want you to use a reciprocal identity to simplify this more. So when I do that, I recognize that this is 1 over sine squared of 3x. What is 1 over sine equal to? Cosecant. So this is the same as the integral of cosecant squared 3x dx. And it allows me to anti-differentiate without using chain rule. So what's the antiderivative of cosine squared? What is it? What's the antiderivative of cosine squared?
Negative cotangent.
Of cosine?
Cosecant. Oh my gosh. It is negative cotangent. Can I actually do this one without chain rule? Not chain rule, use substitution?
I don't know why you would.
Yeah, because it's cotangent and then you add the
Yes, but what part are you not noting here?
3x.
The 3x. So because I have something inside that is not just an x, I still have to use u substitution, but this time I only have to worry about chain rule once. So I still have to recognize my inside function is 3x, which means that my outside function is what? Or not my outside function, the derivative of the inside function,
How is that the inside function?
because it's inside of my trig function.
Yeah, but shouldn't the inside function be cosecant 3x?
No, not necessarily, because this I'm treating as one function, since its antiderivative is cotangent. I already know that. So I only have to worry about what got plugged into it.
So basically, we did that first, the last step first, instead of doing it at the end. Like instead of-
We acknowledged the last step before we did the inside, yes.
Yeah.
We acknowledged it, yeah. Okay, what is the derivative of 3x? 3dx. Do I have a 3dx in my problem? Which means I need to put one in. So because I'm putting a 3 in, I need to balance it out by dividing that 3 out. So because I put the 3 in, I also had to divide it out. And then I can replace my u's and my du's.
Who's that?
It's Liam.
Wait, I missed you so much.
Wish I could have been here.
She was loving
Aaron, where do I put my u and du?
you. You goes for 3x.
The u goes where 3x is, correct?
The T goes after that.
Okay. Now I can anti-differentiate. So what is the antiderivative of cosecant squared u?
Okay, but I thought we did that first.
No, we acknowledged it first. We haven't done it yet.
Cotangent.
Negative cotangent of u, yes. So this becomes 1/3 times negative cotangent of u plus c. Why was it negative cotangent and not positive cotangent? Because cotangent gives me negative cosecant squared. I had a positive cosecant squared, so the negative had to cancel out. And now I can do what? Put my u back in. So this is negative 1/3 cotangent of 3x plus c.
Why does the U even matter about taking it out if we're putting it right back?
We take it out to make it more apparent what our antiderivative is. Because if you saw like 3x to the 8th, you might get freaked out instead of u to the 8th. So it just makes it in its simplest form, which makes taking the antiderivative a lot easier, and then we just plug it back in at the end.
That and you're not taking the antiderivative of that inside.
Correct. Correct. So it's all for ease, believe it or not. Questions on that one?
No,
Okay, let's go to M.
Just a lot of interesting stuff.
I'm gonna watch the video.
I would suggest it. She just keeps writing weird essays.
They're integrals.
my brain hurts.
Mine does too.
Now she's adding
I have a
keys.
headache.
You hate us. With
Who's
everything.
that?
Yeah, he.
No, I would never. It's on Friday.
Yeah.
They thought I was giving them a test when they just spent 3
Now,
hours taking
that's
ISUP.
2 plus sine t, right? Not like 2t sine.
It's 2 plus sine t. T's the curve bottom, my plus is down.
Well, it's inside of
So you're definitely would give it a test, right?
Well, I can't because my first hour is the same class and they were in ISUP, so that would be very, very weird. Other than that, I probably would if I only had one. Okay. What do I do first?
No, you probably do something.
Well, you could probably separate it and then do one of
What do you mean by separate it?
So 6 cosine t times 1 over.
I like that.
Wait, are these the ones with 2 in them?
Okay, so I've got that. We just separate it to look a little bit nicer. One of my reciprocal identities will not work here because I have a 2 plus sine of t being squared, not just sine of t, which means this is probably just going to be a normal u substitution problem. So what's my inside function? 2 plus sine of t. So Brock, what does that make my du? I agree it's co something. Nope, that's CSC. Cosine of what? What are we missing? Cosine of t. Make sure your variable's in there, and then dt. Are we all okay with that?
Sure.
Yeah, sure, maybe.
Oh, hey, this makes things a little easier.
Now what should I do?
Probably
Stop there.
Replace.
Fine, yeah, get the 6 out of it
Why do I need to get the 6 out of there?
so that it fix. I mean, it matches with the cos.
So it matches my du. I need that cosine of t to go with the dt. It has no 6, so I can pull that 6 out front since it is a constant. So this is the same as 6 times the integral 1 over u squared times cosine of t dt. I acknowledge that that matches what my du is, so I can replace that with du, and it becomes 6 times the integral 1 over u squared du. And then what do I do next?
Antiderivative.
Antiderive it, yes. I would definitely move that u squared up to the top because that makes it a little bit easier to work with. In my opinion, you can do it from the bottom if that's how you prefer, but that's definitely how I would do it if I were doing this. So that's the same as 6 times the integral u to the negative 2 du, and I'll let you work on it for a second, and then I will call on somebody to tell me what its antiderivative is.
Wait, what?
Take the antiderivative of that. Kevin, what'd you come up with?
-6 over 2 plus 19.
Before we put the stuff that you back in, what did you have? What is just the antiderivative of u to the -2?
-1 over.
So -1 u to the -1. That's not what I wanted. U to the -1 over -1, right? Which is the same as -6 times u to the -1, which is the same as -6 over u. I just dropped that back down. And then plus c, and then I can put my u back in.
Okay.
You could also have left it up top if that's what you wanted to do. I'll put that. Yeah. So you also could have had that if that's how you chose to do it.
And we're done.
No. How do we feel about that one? Terrible, not terrible?
Not bad. I'm just thinking that I'm not gonna remember all this stuff for.
It's a lot. I know it is. So we'll always practice it. Huh? What's wrong?
Is that 2?
Where did I get a 3? Oh,
I thought 2 plus 19
I thought it
would be 1. I thought it was on the bottom.
Well, I brought it up here because some people choose to write it like this versus like this. They're the same thing. So that you could have written -6 over 2 plus sine t and a plus c.
Update, this bank still hasn't fixed my grade.
we just don't have
Really?
time.
We do have the time. What time is it? We still have 11 minutes.
That's so short amount of time. It's like a short amount.
Example N.
Wait, did you put it in hours?
No, it just says time grade.
Oh, yeah. She's just lazy.
Says twice.
She doesn't check her test.
What side is this?
Okay, so I've given you the integral of tangent squared x, secant squared x. Raise your hand if you think you know what we're supposed to do. Kevin.
I didn't raise my hand.
Yeah, but you started to.
So like, 2 can just go to the outside, right?
I don't have a 2 being multiplied in
You have 2 in the.
as an exponent.
Yeah, like out to the outside exponent. So then your inside function could just be tangent x secant x.
That's what.
You have
To just.
I could, but then I don't want to use product rule to take the derivative of tangent x secant x.
You didn't say what you wanted to do. You said what could we do?
We are not doing that. Emily,
You just do it with the tangent x.
what do you mean I just do it with the tangent x?
Like you just do your inside function is tangent.
Why would you choose tangent of x to be our inside function? Because the derivative is secant squared. So it looks like secant x tangent x, which makes us think that secant x squared or whatever would be our antiderivative, but that's not how it works. So what she's saying is that we should rewrite this as tangent x squared times secant x, or secant squared x dx, and make tangent my inside function because its derivative is secant squared, which is present in this function as well. So u here equals tangent of x. Du then will equal secant squared x dx. So when I replace my u's by du's, this becomes the integral of u squared du, and I can take the antiderivative of that. And then my antiderivative turns out to be tangent cubed x over 3 plus c. After all is said and done. Yeah, I just took u squared,
I thought it
increased and divided.
It was.
I don't even care.
Wow, okay.
Wait.
I have a migraine.
Is that the same as like tangent x in the parentheses?
and then cubed on the outside, yes. They are exactly the same.
Fried mushroom. Those sound kind of good right now.
Fried mushrooms at this kind.
Those two are equivalent, doesn't matter which way you choose to write it. They mean the same thing. Just know that they can be given to you either way, so you should know that they're equivalent to each other. Questions, concerns, or issues with that one?
Only one.
Example O.
Why did you change colors all of a sudden?
I always try to switch from whatever colors
Did
are
you
there.
change colors every time? I really thought you've been using it for a while.
No, I try to switch. No, I guess I don't always, but no, I try to. I try to always switch from the end of one to the beginning of the next.
I swear you've been on pink.
I think you just switched 3 times in the same question.
I'm not saying I didn't do that, but
I hadn't even noticed that though. So.
I don't like having real numbers in these.
You really confused me like a lot because I thought that was 4O. Like O was a different
Oh.
variable.
yeah, no. Oh, we're not there yet.
What?
Oh, that's gonna
If you ever
happen.
use O as a variable, I think I might draw a calculator.
I would make it a theta instead of an O, but no, I would never use O.
We didn't use a theta.
Did you say theta?
The what?
Did you say theta?
Okay, Aaron, what's the first thing I want to do? To make this easier to see and work with.
Split it up.
What do you mean by split it up?
Separate it.
Yeah, but how would you separate it?
Theta.
Well, I put 40 and then put the rest over 1.
You mean 1 over
Yeah.
the rest of it? Okay, so the first thing Erin did was she split it up, which was absolutely the right thing to do.
I don't think you know what just happened. Deanna thought it was theta, and then we said
Like
no. There's a,
theta?
and then
Yeah,
we
like
said no. There's a th, so she said theta.
that is fantastic.
I still have on my work that I got this now.
Oh my goodness.
Anyway, that's okay.
Next.
Can I change my
No.
senior?
Why was this a good thing for Erin to decide to do?
Isn't it like
It is an inverse trig function. So go back and look at your inverse trig functions because there's going to be one that looks a lot like this. We're going to have to manipulate it, of course. But there's going to be one that looks remarkably like that one.
It's gonna be inverse on it.
I want everybody to look.
Oh, I'm looking. I look.
It will be.
I think
Is it like 1 over x?
I just went over here plus 1.
Everybody look at your inverse trig function derivatives. I know, I'm sorry.
I don't even know how far away it is.
Tangent.
Can I just say
it's
it's
like 4 derivatives That doesn't help. It might help.
Wow, no. Oh, it's well, tangent is 1 over 1 plus.
Or x squared plus 1,
Yeah.
right? Is that the one that looks the closest to what I currently have up here?
Yeah.
Yes. The only difference is that I'm doing x squared plus 25, not x squared plus 1.
So I used to tangent to this one.
Nope. That's actually a huge issue. So what I need to do is I need to make this something squared plus 1. What's the only way I can do that? Divide each of these denominator values by 25. So this becomes the integral of 40 times 1 over 25 times x squared over 25 plus 1. I just divided each of them by 25. I also recognize that at this x squared over 25, I need to rewrite as one quantity squared. I know the square root of x squared is x. What's the square root of 25?
5.
Because I divided it out of both of these terms.
Yeah.
So this is the integral of 40 times 1 over 25 times x over 5 squared plus 1 dx.
I feel like we just created a whole lot of problem now.
This is so annoying. Like, why can't we just?
This is honestly, in my opinion, the hardest set of guess.
You're doing stretches back there.
I would like to make this look a little bit nicer. So I'm gonna pull this 25 and make it a denominator under my 40, and I'm gonna put them out front because they're constants. So this is 40 over 25 times the integral of 1 over x plus 5 squared plus 1 dx.
So 8 over 5 then.
We're not there yet. Don't reduce that yet. Are we all okay so far? For the most part. Yes, ma'am. Oh, you're just kidding. You're not doing that. Now is when I can do my u substitution. My u is whatever I'm squaring. So that's going to be x over 5. Which means that my derivative of u is equal to what? 1/5 and then dx. I have the dx in my problem. I have the 1/5. Is that a yes or no? Kind of. Technically, I have a 1/5 here. I just have to separate it. So if I take a 1/5 out of that, this becomes 40 over 5 times the integral 1 over u squared plus 1 times 1/5 dx. So I just divided a 5 out and moved it as a fractional 1/5. And now I can antidifferentiate. I know that the antiderivative of 1 over u squared plus 1 is what? Tan inverse. So this is 40 over 5 times tan inverse of u du. What'd you say, honey? Give him a second. And then plus c. And then, of course, I can go ahead and put my u back in, and I can reduce the 40 over 5. And then that would be your antiderivative of this function. I would definitely.
Whoa, that was